In the autumn of 1943, federal inspectors forced open the padlocked doors of a secret research shed in Lancaster, Pennsylvania. Rumors had reached Washington that a rogue shop superintendent was violating emergency wartime steel rules by secretly melting pig iron to cast heavy 400-pound metal arms. When agents stepped across the grease-stained sawdust floor, they did not find an illegal weapons factory or a syndicate of war profiteers. Instead, they discovered a lone machinist standing before a strange overhead saw assembly, its electric motor suspended from a sliding iron arm high above a long mahogany workbench. Attached to the frame was a handwritten notice: "Do not dismantle. This machine cuts 500 feet of aircraft spruce per hour with a single operator." Inspectors possessed strict orders to impound and seize all unauthorized metal without delay. Yet within 48 hours, the War Production Board reversed its directive. Officials issued a top-priority military clearance and ordered 300 identical units shipped straight to naval shipyards. Why was this workshop invention kept hidden under armed watch in a Pennsylvania barn? How did a single overhead slide rail become a classified asset in the global race to supply the Allied front and win World War II? You are watching Rivet and Rebar, where we uncover the industrial giants and mechanical sagas that quietly built our modern world. If forgotten industrial history, heavy iron craftsmanship, and precision engineering excite you, take a moment to like this video and subscribe to the channel right now. We tell the real stories of the bold inventors, massive foundries, and groundbreaking tools that transformed raw human ambition into world-changing industrial power. Step back to where it all began. Long before federal agents inspected high-speed wood saws, the American heartland ran on raw muscle, steam power, and dangerous, unforgiving iron. At the start of the 20th century, Pennsylvania was the undisputed titan of heavy manufacturing across the globe. Steam locomotives thundered out of Philadelphia factories. Blast furnaces turned the night skies of Pittsburgh bright crimson, and busy lumber mills fed millions of board feet of timber into a rapidly growing nation. Solid wooden beams framed every new factory, bridge, coal mine shaft, and freight rail car crossing the continent. Manufacturing was not managed from comfortable air-conditioned boardrooms back in those days. Hardworking laborers forged heavy equipment on oil-stained concrete floors, knowing the exact balance of a steel bar simply by holding it in their hands. Into this demanding industrial world stepped Raymond DeWalt. Born in 1885, Raymond belonged to a rare group of American inventors who combined practical workshop skill with sharp economic foresight. He did not start his career sitting at an executive desk wearing a tailored suit. By age 14, he was sweeping metal shavings in a local machine shop, watching lathe tools peel curling strips of hot steel, and learning how structural iron beams flexed under heavy-weight loads. Raymond possessed a natural gift for mechanics. He mastered pattern making, iron casting, and manual gear cutting long before reaching adulthood. He understood how cast iron absorbed heavy vibration, how carbon steel resisted wear, and how bronze bushings reduced friction in spinning parts. Listening to a steam-driven line shaft, he could spot a bad bearing 3 rooms away just by hearing the subtle change in sound pitch. High quality was non-negotiable for him. By the early 1920s, Raymond had earned a promotion to superintendent of a large lumber mill in Leola, Pennsylvania. His facility processed vast quantities of heavy lumber for home housing, commercial buildings, and specialized industrial construction projects. But as post-war construction surged across the country, the mill ran headfirst into a severe operational bottleneck that threatened to stop production entirely. The trouble was not a lack of timber or a shortage of willing workers. It was a basic mechanical flaw in the woodworking tools of that era. Standard woodworking machines were pushing workers to physical exhaustion while wasting valuable time and money on unnecessary motion. Picture running a high-volume lumber mill in 1922. Workers relied on heavy stationary table saws, driven by flat canvas belts connected to overhead line shafts. To make a simple angle cut on a 12-foot oak beam, 2 laborers had to pick up the heavy log and manually push it across a fixed spinning blade. If the wood shifted even 1/16 of an inch during the pass, the blade bound violently. That sudden kickback could slam the heavy wooden beam into the worker's chest or destroy a piece of expensive lumber. Setting up a compound bevel cut required tilting the massive iron table bed itself, an exhausting task using wrenches and spirit levels that wasted up to 20 minutes of lost production time. Numbers showed the painful truth. Workers spent 80% of their workday wrestling heavy timber across static machines, and only 20% actually cutting wood. Traditional shops required 30 feet of open floor space around every table saw just to maneuver long boards into position. Old machinery demanded that the material move around the tool. Raymond DeWalt realized everyone was looking at the problem completely upside down. What if the heavy timber stayed completely still, firmly clamped to a solid workbench, while the saw blade moved overhead through a precise, repeatable path? Retreating to his home workshop, Raymond began assembling a workable solution from scrap metal parts. He mounted a heavy wooden post, attached a horizontal beam overhead, and built a sliding carriage with hardened steel rollers running inside smooth guide tracks. Under the carriage, he mounted a direct drive electric motor with a saw blade attached directly to its spinning motor shaft. Making a crude sliding saw was easy enough, but creating a machine that maintained true precision under daily factory abuse proved to be a tough engineering challenge. Raw wood flexed under pressure, room temperatures shifted, and electric motor vibrations destroyed cut accuracy. Turning to heavy gray cast iron, Raymond designed a cantilevered overhead arm with hand-scraped dovetail guide tracks. These metal guide tracks were ground to tolerances thinner than a human hair, 1/30th the thickness of a standard sheet of paper. The overhead arm swiveled 360 degrees on a heavy center column fitted with smooth roller bearings. Solid clamp levers, elevation screws, and indexing pins locked the whole assembly in place with zero looseness. A single machine operator could now glide the balanced saw head effortlessly across a stationary log using just one hand. In one smooth motion, the machine could cross-cut wood, tilt 45 degrees for a bevel cut, swivel for a miter angle, or drop down to cut clean dado grooves. He named his new creation the DeWalt Wonder-Worker. Impact on the woodworking industry was instant and total. Mill output jumped by 300% overnight. Labor costs fell sharply, scrap wood dropped to near zero, and shop floor space doubled because timber could sit flat along outer walls. Raymond stress-relieved every iron casting in outdoor storage yards to prevent warping before precision grinding. Refusing to sell through high markup dealers, he published clear upfront prices, opened a dedicated factory in Leola, and brought manufacturing in-house to guarantee total quality control across every single machine built. By the late 1930s, the DeWalt Products Company had built the gold standard for heavy industrial tools across North America. Woodworking shops, shipbuilders, pattern makers, and train builders viewed the radial arm saw as an essential mechanical cornerstone. Every machine that rolled out of the Leola shop carried a reputation for unyielding strength, setting a benchmark for American manufacturing that few competitors could ever hope to match. But the biggest test came when global war erupted across Europe and the Pacific. World War II transformed American factories into a massive wartime producer, demanding record speed under extreme operational stress. America's military needed millions of barracks constructed fast. Defense projects needed ammunition boxes, wooden bridges, cargo supply ships, and light wooden gliders for airborne troops. The War Production Board issued tough directives. National wood processing capacity had to double without expanding existing factory building sizes. Raymond responded by running his Lancaster plant 24 hours a day, casting heavy iron day and night to fill emergency military orders. Demands on the machinery were brutal. In naval shipyards from Norfolk to Puget Sound and across cargo shipyards in Oregon, heavy DeWalt radial arm saws ran for weeks without stopping. They cut thick white oak, Douglas fir, and teak woods for ship hulls, work scaffolding and transport decks. Dirt, wet sawdust, and corrosive sea salt spray coated the machine beds. Yet heavy cast iron covers shielded the electrical motors, while sealed ball bearings glided along hand-scraped tracks without sticking or jamming. Military engineers deployed truck-mounted mobile saws right behind front lines in North Africa, Italy, and Pacific Island mud. Soldiers constructed combat airfields, floating pontoon bridges, and defensive timber walls under heavy enemy artillery fire. Simple grease fittings allowed troops to service the machinery quickly in torrential downpours. In the scorching desert heat of North Africa and the freezing rains of the Italian campaign, these rugged machines worked relentlessly day after day, without breaking down or losing their precise alignment. The United States Navy awarded DeWalt the prestigious Army-Navy E Award for Industrial Excellence, flying the honor flag over the Lancaster plant. Factory workers pushed forward with total focus. When light stamped metal tools broke their bearings and warped from heat, DeWalt's heavy cast iron swallowed the vibration, keeping cuts razor-sharp through millions of continuous passes under grueling battlefield conditions. Consider the mysterious shed in Lancaster back in 1943. When federal agents entered Raymond DeWalt's locked shop, they thought they were stopping an illegal iron stockpile. What they actually witnessed was the final secret development of the heavy-duty Model GE radial arm saw, a machine engineered specifically for extreme aircraft precision. Shortages of aluminum and steel during the war forced airplane designers to build combat gliders, like the Waco CG-4A, out of strong spruce wood and birch plywood. Building these wooden aircraft required tight accuracy, normally reserved for watchmaking or locomotive engine building. A single misaligned wing spar joint or improperly cut fuselage notch could cause a fatal structural crash during heavy dive maneuvers or unpowered combat landings behind enemy lines in Normandy. Standard saws could not hold compound miter angles during high-speed work because motor friction expanded the slide arms, causing cuts to drift off target by several thousandths of an inch. Raymond solved this difficult engineering problem in secret. Inside his locked barn, he designed a smart internal heat compensation system using spring-loaded guides and bronze keys that balanced out heat expansion under long electrical runs. The saw could run at full power for 16 straight hours while keeping angle cuts accurate within 1/60th of a single degree across a 30-inch board. Military inspectors tested the wood cuts with precision measuring devices, finding zero measurable error across dozens of consecutive wing spar assemblies. This mechanical perfection saved soldiers' lives on the battlefield. Realizing what Raymond had accomplished, War Production Board officials turned their suspicion into praise. The machinery was not wasted metal. It was the key to mass-producing combat gliders for upcoming invasions in Europe and the Pacific. The Pentagon classified the internal slide arm designs as a war secret, prohibiting publication of detailed drawings until victory was secured. That padlocked barn had not hidden illegal trade. It had protected the mechanical backbone of Allied victory. Following the war, DeWalt grew rapidly alongside America's suburban housing construction boom. Hundreds of thousands of new suburban homes required timber framing, putting the radial arm saw at the center of almost every major job site in the nation. As neighborhoods expanded across suburban landscapes, Contractors depended on the radial arm saw as the workhorse engine of every major housing development from coast to coast. But as Raymond approached retirement age, the industrial market began shifting away from craftsman manufacturing toward corporate buyouts, Wall Street conglomerates, and asset consolidation. In 1949, Raymond DeWalt sold his company to the American Machine and Foundry Company. 10 years later, in 1960, tool maker Black & Decker bought the brand. For decades, the DeWalt name remained synonymous with heavy, indestructible cast iron equipment. But by the late 1980s, the global tool market changed dramatically. Foreign competitors flooded stores with lightweight, low-cost power tools made from stamped steel and plastic housings. Corporate executives in suits replaced experienced shop managers who had spent lifetime careers on foundry floors. Management viewed DeWalt's stationary radial arm saws, built with thick iron castings, heavy induction motors, and hand-fitted slides, as inefficient equipment. Heavy cast iron was expensive to melt, costly to ship, and lasted too long. A machine built so well that it never broke produced no repeat sales for a public company seeking quarterly profit growth. Production gradually shifted toward lighter materials, thin metal stampings, and plastic bodies. In 1992, Black & Decker executed a major brand redesign. They launched their full line of portable job site power tools under the iconic DeWalt name, using bright yellow and black colors. This commercial strategy succeeded financial-wise, making DeWalt one of the top-selling power tool brands worldwide with billions of dollars in global sales. The strategic move transformed a legacy machinery brand into a ubiquitous household name, recognized by professional contractors and DIY enthusiasts across the globe. However, that business pivot changed the original spirit of the company. The heavy stationary radial arm saws that built the enterprise were gradually discontinued, replaced by portable job site miter saws built for quick consumer replacement rather than long family hand-downs. Corporate focus moved to plastic bodies, battery packs, and overseas assembly lines. But the physical iron poured by Raymond DeWalt refused to quit. Visit an old-school woodworking shop, custom cabinet builder, or independent boatyard today, and you will often find a vintage DeWalt radial arm saw built in the 1940s or 1950s, standing tall on a heavy cast iron base, its green or gray paint worn smooth by millions of wooden boards. The machine still glides smoothly across tracks with silky perfection. Woodworkers buy these 70-year-old iron tools at estate auctions, clean off decades of dried grease, update the electrical wiring, and put them straight back to work. Craftsmen frequently upgrade these vintage iron arms with digital sensors, carbide-tipped blades, and solid-state motor drives, making cuts that easily outperform brand-new $5,000 tools. Reflect on what that shows us. Conglomerates bought and sold the business pats. Corporate executives retired with lucrative stock options. The original factories were knocked down or converted into residential lofts. But the heavy cast iron machine, handcrafted in a Pennsylvania foundry nearly a century ago, continues cutting wood accurately to 1/1000th of an inch every single day. The company changed. The machines endured. You have been watching Rivet and Rebar. If forgotten industrial sagas and precision engineering resonate with you, take a second to like this video and subscribe to the channel right now. Click the video card on your screen right now to step into our next documentary on heavy machinery and corporate history.